Thank you, Dave. Thank you, everyone, for being here with me tonight. So today we're going to talk about some kung fu thing. So I'll start with a story. A long time ago, I had the luxury of getting to know and learn a lot from a close family member, a man with excellent integrity. He passed away years ago, but I could still remember all the fascinating stories that he told us. How he drove my parents to the hospital where I was born to this wonderful world, to all his crazy traveling because of his particular line of work. So in that line of work, he also needed to master several languages. I'm talking about human languages here, not computer languages. Everything from Dutch to Japanese and Mandarin to Arabic. These days, there are many different ways you can use to measure your language skills. But back then, when I was still alive, I asked about being able to have a good command of a language, and what he told me is something that I will never forget. According to him, there's a simple yardstick that you can use to see whether you're comfortable using a language or not. One, you can tell a joke in that language. And second, if you're upset with somebody, you can express your anger or disappointment to that person in that language. Now, it doesn't mean that you have to be funny or angry all day long. However, this simple yardstick is quite literally simple, and yet it's quite powerful. I think what we need in this front-end world is some simple yardstick like this to see, after you become seasoned or experienced front-end developer, what do you need to do? How can you know that you're past a certain level? If you start any front-end project these days, there are a couple of steps that are obvious to you. First, you need to pick a certain framework. It could be Angular, React, Ember, your favorite. And then you need to come up with a strategy for your testing. Pick a unit test framework, come up with a CI system, put it in your build environment, all the usual steps. And maybe after that, you choose a way to analyze your code statically, whether it's using JSLin or JSHin, ESLin, JSES, what have you. But after this, what do you need to do? And looking around, asking many people about what they need to do, I figured out that there's no common answer. There's no clear path. Okay, I've picked my framework. I've done my unit tests. I've done some static analysis. So what next? I mean, we've been practicing TDD and BDD for a while. How many of you here practice TDD? BDD? All right, should we become more pragmatic and practice pragmatic-driven development, aka PDD? What we need to come up with is some sort of formulation that defines the path. If you want to be a front-end hero, this is what we need to do, because you may not admit it, but we all like to be a front-end hero, right? Because you either die a JavaScript hero. Anyone familiar with this type of sentiments in the front-end world? You want to tweet that? Go ahead, I'll wait. So for the rest of the talk, I'll outline 5 steps that allow you to move to the next level. And now, these are not set in stone, meaning that you have completely followed this faithfully, but this sets an example or a guidelines as to what you need to do. In order to be able to follow along at your convenient time, I create this simple project on GitHub. Go to github.com/Ariya/from 0 to hero. And there is a modified version of the React to do MVC. Nothing special about that app. I just picked some sample app that has enough code to be meaningful, yet small enough for everyone. And I added some tests into that app, obviously, because strangely enough, this to-do MVC app didn't come up with didn't include some tests. So the test is using Chai as the insertion library and Mocha as the test library. Again, you can use Jasmine or QUnit or whatever you like. And then in that particular project, I'm using Karma as the test runner. Karma will pick up all those Mocha tests and launch the test in many different environments, from Phantom.js, headless browser, to Chrome, Safari, any kind of browser that you can specify. And then I added JSCS. Anyone here using JSCS? Well, if you haven't used that, please check it out because it's really cool. It allows you to have a uniform coding style across the project. So you can clone this project, not right now, later, and then you can see some of the kung fu moves that I plan to explain after this. So if you type npm start after you clone that app, obviously after npm install, then you can see that it just serves the content. You can open it up in a web browser and you'll see the familiar to-do MVCI. Nothing magical up to this point. So first step, Git hooks. Anyone here is a big fan of other revision control system than Git? Any Mercurial fanboys in the house? Seriously, come on guys. Fossil? Yeah. Good. Subversion? Perforce? Git has these powerful hooks, and it is amazing how a lot of people, after using Git for a while, haven't discovered this. How many of you haven't used Git hooks? All right, so the very least, those who haven't used Git hooks, if you start using Git hooks tomorrow or after the talk right away, you'll make me really happy. So next time I'll show up at this meetup, hopefully everyone says, yes, I use Git hooks. There are a couple of hooks defined with Git, but we can take a look at the most common ones. So Git hook. There's something called pre-commit hook. What it does is, a hook is just a script. And in the context of pre-commit hook, Git will run your pre-commit hook, your script, before it tries to commit whatever you have in your working directory. And if the exit code is 0, I'll continue and do the commit as usual. If it's not 0, then it'll stop. Your working directory remains dirty as is. Nothing will be committed. Usually we don't realize this because it happens behind the scene, and you notice this until you have a pre-commit hook. There's a similar thing, a pre-push hook. I don't know if you're familiar with these scenarios, but many times I push my feature branch thinking that I got everything already sorted out, and turned out there's a lot of bad commits and stuff that I need to clean up. It's just embarrassment because once you push it out there, it's for everyone to see. Pre-push works very similar to pre-commit, except that it does run your hook right before the real push. So if your script, your pre-push hook fails, in other words, it returns non-0, then it won't be pushed. Your branch will stay locally. Now, this is powerful because this is where you can put certain sanity check. A very popular way to create a hook is just to write a script. And this is, if you just copy and paste these 3 lines, suddenly you got a commit hook, pre-commit hook that says npm run JSCS. Next time you try to commit something, it will be executed. But the gotcha here is that you have to set the file to be executable, hence the change attribute to +x. If you forgot to do the second part, it will lead to mysterious bugs that will waste you hours. So just copy and paste this, you'll get a very simple pre-commit hook. And you can put whatever you like. Instead of npm run JSCS, maybe you have grunt script or task or gulp task that runs, I don't know, JS hint for you. Here's an example. Say I have created this on that particular sample application, and then I try to commit a fix. But if I violate the code style, JSCS will complain, and by the virtue of that pre-commit hook, it will stop the commit from happening. Again, this indicates that I use single quote. JSCS kindly point out that I use single quote on that, although my coding style mandates that I use double quotes for string. In other words, accidentally, if I introduce some new code that doesn't follow the existing coding style, JSCS will complain, and I won't be able to commit that at all. Any questions so far? Of course, you can do the same with pre-push hook. Now, here's the trick. Typically, you don't want to run something crazy in your pre-commit hook. If it launch a web server and talk to some backend database and spend 5 minutes doing its check, then you're not going to run it. You want to choose something that is very, very simple that most of the time you forgot to do that. NPM tests, if you have a reasonably fast unit test, that will be a suitable candidate as well. So choose wisely, run a basic sanity check, and put that in your pre-commit hook as well as pre-push hook. So that was easy. The second one, I'm going to talk about code complexity. So code complexity is quite complex, pun intended. Fortunately, there's a website that explains everything you need to know about complexity. Just go to jscomplexity.org. Then there's a box there where you can put your code and it'll show up all the fancy metrics from cyclomatic complexity to any other maintenance factor. So let's take a look at the cyclomatic complexity. Not going into details, but cyclomatic complexity roughly proportional to the amount of different code paths that is taken in your code. So this one is very simple, but if you have something like this, so if branch, and it goes to the left, right, up, and down, then your number will go up. So that's all you need to know. There's no scientific value in the number itself. It doesn't correlate to something physical. Obviously, you want to have as low complexity as possible, and this is where the tools JS complexity plays an important role. If you install the package, the node package, then you can also run or check for complexity on the command line. It's called CR for complexity report, and you'll get all kind of report like this. And cyclomatic complexity is just one of the metrics that you will be able to obtain there. Note that complexity report will scan your source code and analyze it statically and will come up with the complexity per function. And this is very important so that you can come up with an implementation of a certain function, and then as soon as it reaches certain threshold, I don't know, maybe 6 or 12, or use your best judgment, then that's an indication that you might want to start to refactor that function, split it into small function, simplify it, do whatever necessary so that that particular function doesn't have tons of different combination of code path. I'm sure in your life you have seen this huge 2,000 lines of function that is impossible to debug, let alone refactor. And we want to avoid to be in that state. And the best way to do that is to prevent your code to turn into spaghetti like that. So that's about complexity, I believe. Is it easy or complex? All right, the third one, getting there, we're halfway. Code coverage. How many of you track code coverage of your application? Wow, again, for the rest of you, it's that easy. I'll show you the tricks here. The popular tool for code coverage is called Istanbul, and it works by having two very important modules, instrumenter and coverage analysis. So the first part, instrumenter, is very easy. If you have a test and you want to run the test against your application library modules, for code coverage to work, it needs to know which part of your library module application will be touched by that unit test. And therefore, you don't run your unit test against the original source. You run it against the instrumented version of the source. Combine it with tests, you'll get coverage reports. This is the beauty of using test runners such as Karma, because you can use several plugins for Karma to perform unit tests. So if you already have Karma configuration file that looks like this, all you need to do is add a new Karma-coverage plugin in the list of plugins, and then run some preprocessor, add coverage there, and create a reporter, and then choose the type of reporter that you want to have. Again, this exists in the sample repo that I've mentioned earlier. If you do that, and you can open coverage report, it's a normal HTML, open it in the browser, and you'll see something like this. Remember earlier I mentioned that I added some unit tests into that to the MVC, but I wasn't finished. So there are some functions that have no corresponding unit test at all. And we discovered that right away because those lines on this function are highlighted with the very bright red background over there. That means that Those are uncover JavaScript statements, which mean that no tests touch that particular code. Or phrased differently, that function is not tested, which is pretty scary. Consider that it's a very important function, subscribe and inform. Now, using this trick, that means you can take a look at your modules, library, application, what have you, and discover, oh, my unit test doesn't cover this part, my unit test completely ignore this part. And the worst possible scenarios is that you have multiple branches using if statement or other conditional, and you realize that you spend hours coming up with unit tests that only worries about one particular side of the code and completely ignore the rest. Would be nice if the world can see your code coverage. Well, only if you have good code coverage, of course, otherwise it's sort of public shaming. In this particular example, I wired up a code coverage dashboard service called CodeCov. There are many services like this. I picked one. And what you see when you run a local coverage test is exactly what you see on that dashboard. So your teammates, the world, can see that my coverage here is not pretty good because one is 77%, the other one is 92%, which is okay. How does it work? Well, you have to integrate it with your build system or build environment. So you have your code repository and build system. In this particular example, I use Travis CI. You need to send your coverage report to the dashboard service, in this case, CodeCov. Or you can also use coveralls, which is pretty popular. Even better, if someone come up with a pull request because they created the feature branch, that coverage check can be run in that particular feature branch. And in this case, CodeCov nicely or conveniently tells you if coverage suddenly regresses. Code coverage itself as a metric is just a percentage. It's probably not so meaningful. Obviously, it would be nice to have 100%, but 90% is also not so bad. 80% is probably okay. But what you want to watch is a regression. If my project has 100% code coverage and you are a new contributor and suddenly you contribute a huge improvement or bug fixes, and suddenly the code coverage regressed to just 50%, that indicates that you forgot to include some tests for all the new lines of code that you just created. So the regression is the one that matters, not the absolute value. It would be nice if that regression is reported in the pull request. Here's an example. It says that, well, previously the code coverage is 100%, now it's down to 80% because there are some lines not covered by the test, or the test doesn't exist, or the test is not sufficient. By catching it early on, then you will not allow any kind of code that doesn't have corresponding test to enter your code repository. This also reduces the personal aspect of the code review, because if you create a pull request and I tell you, hey, your code coverage sucks, you might be offended. But this is a tool that tells you that your coverage regressed, so what will you do? You can smash your laptop, but not good for you. Yeah, so this is a fantastic quote by Dave Glass. He works for Yahoo. If you think Jaslyn hurts your feeling, wait until you use Istanbul for doing code coverage, because your heart will be broken into pieces. You think you're doing a good job at building and maintaining your unit tests until the reality kicks in and realize that, oh, no, I'm not actually testing my application. If you are doing code coverage for the first time, I suggest playing this in the background, because you will be miserable and sad and unhappy. So I think it fits your situation there. This is Wham. Any Wham fans in the house? Oh, okay, good. All right, so that's about code coverage. We're halfway there, speaking about coverage. Number 4, running your apps with evergreen browser. So evergreen browser is the browser that is constantly updated to the latest version. You're familiar with Chrome and Firefox, and now Microsoft Edge on Windows is also considered evergreen browser. It is very tempting to run your tests in 300 different combinations of browser, from browser on BlackBerry to, I don't know, the latest iPhone that is not out yet. But it's good. However, remember what I mentioned earlier about pre-commit hook and pre-push hook. If possible, run your apps in the with the evergreen browser as soon as possible, because it's supposed to be fast, it's supposed to be cheap, and if it doesn't work already in the latest version of Chrome and Firefox, why bother testing it on BlackBerry and other devices? By that time, all bets are probably off. Imagine you build an email application. If someone could not log in, if your login test doesn't work in Chrome, then forget about the rest. So the trick here is to be able to have an environment where you can run the latest version of the browser for your application. Surprise, there's this things called AppVeyor. This is a CI for C# and .NET application. Any C# .NET fans in the house? It's probably the wrong question for JavaScript Meetup. This is, however, very popular in the Windows world because it's essentially, you can say this as a traffic CI for Windows. You may dislike Windows, however, there's one nice thing about Windows. It has a third-party package manager. Surprise! Who would thought that Windows is package manager? And there's a nice wrapper around that called Chocolatey. So you can just, after you install Chocolatey, you can type Choco install Firefox and boom, on your, or should I say Skadooz, since it's Kung Fu Panda, right? Suddenly you have the latest version of Firefox on your desktop. Same thing with Chrome, Google Chrome. When you think about Windows, usually you think about opening IE, go to google.com/Chrome and click on the link and then install it, click next, and then there you have Chrome. That is not Windows this day. Your information is outdated by at least 5 years. Today, you can have a package management on Windows. And this is very powerful because apparently a virtualized environment of Windows running on AppVeyor allows you to install tons of Windows applications on your desktop. And this is what we leverage here. If you create an AppVeyor YAML file and put it in your project and sign up with AppVeyor, there's a free tier for that, and you run your apps, suddenly you can do this. You can do this magic. Remember, this app is just Node, and Node run on Windows. I feel like I'm promoting Microsoft a lot here. And if it runs these steps, then what happens is it's going to, oh, there's a screenshot. Yeah, if you want to know what package is available, you can go to this website. And it even has a nice copy and pastable one line that you can use to install whatever package that you like. Here's what happens in the built environment if you do this. Choco install Firefox will look up some registry somewhere and then download it, install it for you, and you can start using it. Same with upgrade Firefox. Sometimes it's necessary to do install and upgrade because you don't know what packages are already available in the system. If you do this, what you have is the latest version of Firefox and Chrome, and it's that easy. Any questions so far? So last but not least, well, there's something called, there's a concept called the downstream project. And this is not so popular yet, so I'm doing my best here to campaign for this strategy. Everyone here is probably building apps with Node, and one of the most popular apps is Express. But if you think about all the stack that allows your Express apps to be used by your users, well, Express is running on Node, so obviously there's Node there. But Node, the major chunk of Node is a JavaScript engine, V8, the same JavaScript engine that powers Google Chrome. What I mean by downstream here is that Express is a downstream project for Node. Node is a downstream project for V8. And why is it important to pay attention to this? Because in today's world of complicated and sophisticated web apps, you may accidentally break your downstream dependency without realizing it. What if the next version of Node doesn't work with your version of Express? You'll cry. Or what if Google changed V8 so that Node doesn't run anymore? Obviously, it won't happen, but in that hypothetical scenarios, suddenly the internet doesn't work anymore. And you can think of this as there's a library, and the library builds a framework, because if you imagine that framework is a collection of several libraries, and then there's your app. So if you're an app developer and you use a library from your coworker, then you should be nice to them because they might not realize that their library is being used by you, and therefore if they introduce something that breaks your app, that's not good for you. So in this spirit of being nice to your downstream, what you have to do if you're a framework developer, if you build Ember, if you build Angular, if you build React, you need to find out all the popular projects that use your framework and test it for every updates that you have in your framework. So it's a bit backward. Usually we worry about that direction. Now we worry about this direction. So you care about your user. If I write library X and it's being used by this person over here, maybe it's being popularly used by this person over there, then I try to come up with a way not to break that particular use case. Apparently to achieve this is so easy that it fits in a nice screen. Oh, by the way, this is a nice example. To do MVC, obviously, there's a to do MVC that relies on backbone. Backbone uses underscore. So if underscore breaks backbone, then many apps out there that relies on backbone won't work anymore. So if you're an underscore developer, you should pay attention that backbone is not broken by your updates. Same with backbone and to do MVC. It's so easy to do this that it fits in a slide. This is a concept of testing your downstream project. A couple of steps there. You clone that downstream project, and then you install a dependency. I'm assuming this is just a normal node project. And then you replace your awesome library that is in the copy of that downstream project with your fresh version and put it there and launch that downstream project unit test. So essentially, you're checking out that downstream project and replace your library with your own copy and see if that works or not. This is very simple, and yet it's very powerful. And if you're crazy, run it for every single pull request and every single commit, so that you know you can give a heads up to that downstream project. Hey, I'm about to break your apps. They will hate you, but they will hate you less compared to surprise, your app won't work anymore once you publish your new package. Any question about the downstream project test so far? All right, so bonus. Now that you do all these things, checking code coverage, checking code complexity, run downstream project, something that came to my mind as I tried to follow all these pathways, turned out that you don't need to do this sequentially. You can do this step by step. Check the code coverage. Oh, it's good, and then run cross-browser test or evergreen browser, and then finally check your downstream project. No, you don't need to follow this pattern. You can do everything at once, like this. Who said that you cannot check the downstream project before you know that your coverage is good? So if all the downstream project is good after your update, but your code coverage regresses, then you just need to fix that one. This also saves a lot of time, because sometimes running extensive tests, such as cross-browser testing, is the most expensive and the longest among other tests. So rather than waiting 15 minutes until your 200 browser tests finish to look at the code coverage, you can do that right away. And to make things even more amazing, you can run this on different servers. If you're using open source project, one of them can run on Travis, the other can run on Jenkins, and there's too many free CI systems these days, so why not leverage all of them? So I hope some of these steps, some extra kung fu move that you learned today will allow you to make a better front-end developers. And thank you very much for your attention.